So we'll be working on Venn diagrams today. Now, Venn diagram is a pictorial illustration of sets. For example, we have the two subsets and the three subset Venn diagram. We're starting with two subsets today. Then we'll work on problems on two subset. Now, this is a Venn diagram made up of a rectangular box. Then you have sets inside made up of circles. So let's call this set A, and then this is set B. Now, every element inside this diagram is known as the universal set. Understanding every aspect of the diagram will help you know how to solve problems with the diagram. Now, let's make it bigger. So this is the universal set, which means everything in the diagram. So let me just illustrate that. It means every single element inside this diagram. Now, if this is set A and this is set B, what is this part here? Now, notice that this part is the connection between A and B. Most times we know that it's the part where a value is common to both A and to B also. So we're going to call it the intersection. Let's call it X also. So that means A intersection B is equal to X. Now what about this side here? Now this side is the part away from X, meaning that if you remove the intersection part from A, you're going to get just this side here. So what will we call that side? So if we remove this intersection part from A, it will be A minus X. This will be this side. The same thing would be B minus X. If you bring them back together, you see that it actually forms the same thing we're working on. So if you bring A minus X plus X together, you see that you still get A. If you bring B minus X plus X together, you still get B. So this part here, we normally call it A only. So sometimes you see it's known as A only. So it means the intersection removed from the set of A is known as A only. The same thing as B minus X is known as B only. All right? And we know that X is the intersection. Now, what about when you join the two sets together? So if you join these two sets together, we call it A union B. So this means that you're going to combine all the elements in A, the intersection, and also B. Now, when you do that, you're going to have, let's see, you're going to have something like this. Just a moment. So if you combine everything inside, A union B will be equal to A minus X, which is for the first set, plus the intersection, plus B minus X. And then if you bring them together, you have A minus X plus X plus B minus X. Now, minus X and plus X will cancel because minus X plus X is 0. So we'll be left with A plus B minus X. Now this forms the formula for A union B. Normally it is written as A union B equal to number of elements in A plus number of elements in B minus the intersection, which is number of A intersection B. This formula you see here is what you'll be using to solve many of your set problems, especially two subsets. So two subsets are sets that contain just two sets most times. So this is the formula you'll be using. To get the union of the two sets, you're going to have to use the number of elements in A, plus number of elements B, and subtract the intersection. Now, there's something you also need to know. Sometimes the universal set is equal to A union B. Now, this means that every aspect of the universal set is just elements in A and B. Meaning that if you have a Venn diagram where this is set A and this is set B, you're just going to have elements in maybe A union B, maybe the intersection also, but you're not going to have any other element attached to it. No other element here, here, or anywhere. Everything inside here is universal, making A union B equal to the universal. But sometimes the universal set is equal to A union B plus any other set, any other element in the universal set, in the Venn diagram, sorry. This is an example. If you have two subsets, or two subsets here, where this is A and this is B, and you have elements inside A, and then let's call this the intersection, and this is B, and you have another element here, which is not an element of A and B. Normally we'll call it a value that is not attached to A and B. Now, this part here is also the universal set. It is the union of A and B plus the value outside A and B. That is where A union B is not equal to the universal set. But when there is no value outside A and B, then the universal set is equal to the union of the two sets. We're going to be solving problems on that and you understand better. But for now, this is something you need to know, at least in terms of knowledge. So we've gotten the general idea of two subsets. We've seen the different parts of the set, and we've seen the formula on how to solve two subsets problems. We're going to be working on examples and see how we can tackle it. That'll be in the next video. But if you like the video, you can give us a thumbs up and also subscribe. That would be appreciated.